people have been super curious about what was around before the Big Bang. It's a huge head-scratcher, not just about the universe itself, but also what we can even know. Like, imagine standing at the very beginning, wondering what was there before. The Big Bang is where everything we know starts: time, space, the whole deal. But was there something before that? Could there have been a time before things went boom? And if so, what was it like? When we ask this question, science takes us into some wild ideas that turn what we think we know upside down. Brian Cox, a physicist who's good at explaining space stuff, says that something mind-blowing might have been kicking around before the Big Bang. He wants us to think about reality differently. In this chat, we're going to unpack the science and some possible ideas so we can get our heads around what might have been before anything we know. We'll check out theories about quantum weirdness, dark energy, and even other universes. The answers might just blow your mind and maybe even change where you think we fit in the cosmos. Let's jump into a world that's more amazing than you can imagine, filled with puzzles that still have scientists scratching their heads and even questioning everything. To understand what was there before the Big Bang, we first need to know what the Big Bang actually was. Scientists say it was the moment when the universe was crazy hot and squeezed tight, and then it suddenly blew up fast. That's when matter and energy started showing up. When we look at stars today, we see leftovers from that hot start, with galaxies zooming away from a central point. But why did this all happen? And was there anything before the heat? Well, according to a theory called cosmic inflation, the universe before the Big Bang was icy and empty. But not completely empty. It had tons of energy that caused space to stretch out super fast. This speedy growth, called inflation, happened so quickly that it set the stage for everything that came next. Then, the expansion cooled off, and the energy turned into matter and forces, like the Big Bang. But where did this energy come from? And why did it suddenly decide to make a universe? Some scientists think this inflation made separate pockets of the universe, each with its own Big Bang. Imagine an endless sheet with bubbles popping up all over. Each bubble is a different universe, including ours. This idea, called the inflationary multiverse, says there could be a crazy amount of Big Bangs and universes. Our universe is just a drop in the bucket. This mind-bending idea challenges how we think about the cosmos and makes you wonder, what else is out there? The idea of nothingness isn't based on hard facts. But even if you sucked out all the energy, particles, and radiation, the universe still wouldn't be totally empty. Space is full of dark matter, dark energy, and quantum fields, forces and energies that make up everything. Yep, even empty space. Imagine stripping those away, too. Space would still have different types of energy. This alone has scientists stumped, because it suggests real nothingness might not be possible. Space itself has properties and rules that stop it from being totally empty. Imagine a spot with literally nothing, no particles, no energy, no radiation. Just quantum fields and constants. These fields would still be around. So even this nothingness has stuff going on. One of those things is something called zero-point energy, which is the lowest possible energy level of quantum fields. Even at that point, particles can pop up and vanish, creating weird activity in what's supposed to be empty space. This messes with our idea of nothing and suggests that even before the Big Bang, there might have been something that scientists are still trying to figure out. One of the most out there ideas in science is eternal inflation. If inflation could make our universe, it might be going on forever. Brian Cox talks about a huge, endless inflationary multiverse where universes are popping up and growing all the time. Imagine each Big Bang as a spark that makes a new universe, while inflation keeps going in other places. This could, in theory, go on forever. This idea of universes birthing other universes is wild, giving us the possibility of a fractal universe, where each new universe makes its own Big Bang. Each universe would be on its own, untouched by the others, because space is growing so fast. For scientists, this is both exciting and unnerving because it suggests the universe doesn't have a real beginning or end. Picture our universe as a little piece of a much bigger, never-ending design that's always expanding and making new universes. What if there's no beginning or end, but just a cycle of universes being born and dying? The way we think about nothing changes when we think about quantum field theory. This theory says the universe isn't just a bunch of matter floating in space. It's a crazy web of energy fields that work together to make everything we see. These fields are like unseen oceans, with particles acting like waves. Even when these fields are at their lowest, known as the vacuum state, they're still moving. Particles can appear and disappear in these fields, taking energy and then giving it back. This creates virtual particles, particles that only exist for a split second before vanishing, leaving a trace. Virtual particles mess with the idea of complete emptiness. Imagine a completely empty universe with no matter or energy. Would you really have nothing? Nope. You would still have those fields that are constantly moving, sometimes making particles. This shows that the universe doesn't care about our idea of nothing. These fields and forces keep things going, filling space with hidden energy that stops complete emptiness. This makes you wonder, if fields make particles, and particles make matter, could the universe itself have come from this quantum field-filled nothing? Dark energy is a mysterious force that makes the universe expand faster. Some scientists think the dark energy we see today could be leftover from before our universe started. Some theories say dark energy, or a stronger version of it, may have been the thing driving the early universe's crazy expansion. The fact that dark energy even exists suggests that even if all the matter and radiation were gone, this force would still stretch space. If dark energy was around before the Big Bang, could it have created the conditions that made our universe? As we consider that, we see dark energy as not just a force now, but key to understanding the multiverse itself. There's a theory called cyclic cosmology which offers a different view of the Big Bang. Instead of seeing it as a one-time thing, it suggests that the universe goes through cycles of birth, death, and rebirth. The Big Bang isn't the beginning, but just part of a cycle where universes grow, collapse, and are born again and again. This theory says our universe could have come from the remains of one from the past. Expansion and contraction, that means there was no true beginning, but just a never-ending sequence of universes being born, living, and dying. For scientists, this is a good way to answer the question of where things started, because it suggests the universe has always been around in some form. Gravitational waves are an exciting thing that could help us get what was happening before the Big Bang. These waves, predicted by Einstein, were detected, showing that our universe vibrates deeply. Gravitational waves could, in theory, let us look back further than we ever could, potentially past the Big Bang. They could give us clues about the universe formed, showing other forces, or even other universes had an effect on how ours came to be. Scientists are hoping something from the time before the Big Bang. As we think about what came before the Big Bang, it's clear we're just scratching the surface of things. The question still stands, what truly existed before everything? The answer may be stranger and more incredible than we can even imagine. As we keep digging around, we're going deeper into science that's not set in stone. Some concepts push what we can understand, others give us a new way to look at how it all came to be. It's important to remember that investigation remains uncertain. While we can see clues about how old the universe is, seeing what clearly happened before the Big Bang is not possible. This does not mean that looking is pointless. Instead, the ride itself may tell us even more about how things work than we can dream of. One huge idea is time itself. We know the Big Bang is the start of time and space, so going before that is tricky. According to Einstein, time and space are linked as one thing called spacetime. So, asking about before the Big Bang doesn't make sense because time probably didn't exist before then. If time came with the universe, there might have been no before to talk about. We also have to think about our idea of past, present, and future. If the universe and time were created together, how do we even think of it? Time might be something that can squish and stretch or loop. It's all just so hard to understand. These ideas make us remember that the universe has rules that are way beyond what we normally see. One theory is a quantum fluctuation. In quantum mechanics, particles can quickly pop in and out of nothing. So, the entire universe might have just appeared from nowhere in such a fluctuation in a quantum field. So, we might have emerged from a nothingness that was not completely nothing, but a quantum field that wavers. Even before the Big Bang, there could have been a quantum void with potential. There's also a theory about a big bounce. It says each Big Bang is a rebirth. The universe is in cycles of shrinking and growing. Our universe might have been preceded by another. It got small until it gave birth to the universe we know. These get ideas from string theory and quantum gravity. With better devices, we may find indirect evidence. The James Webb Space Telescope captures light from galaxies in the distant reaches, is revealing the conditions of the early universe. Scientists what was happening right after studying cosmic phenomena. Doing so may help us to see that could help us dig into where it all came from. Quantum gravity describes space where quantum effects and gravity are true. It gives us a picture of the origins of our universe and could expose its state. Our arrangements may even create the notion that our universe might not be the one. Another could also be universes where events roll out from we see in our universe. Despite the big questions about answering what there was before the Big Bang, the search of knowledge pushes our understanding. Whether we reveal a pre-Big Bang universe or find new things about time and space, the universe makes us continue searching. No matter how unanswerable in our journey, knowing our question is what makes us who we are. Knowing the drive pushes paradigms in science and principles.